All right, hey everyone. So welcome to discussion 0 for data structure algorithms online. This course is really fun, so I hope you'll enjoy it. Yeah, as I said, today is just discussion 0. We're gonna do a C++ review. I'm gonna introduce myself, introduce the course, and that's about all. Okay, next slide. Oh, ATAs, that's me, or peer mentor. Also Josh. Josh was great. So if you have any questions for either of us, you can always message on Slack or email. It's also good too, at least for me. But anyway, so I'm Andrew Kennedy. I'll be your peer mentor for this course. I'll be leading the discussion. And Josh and I will both be fully officers. I'm a fourth year student at the University of Florida. I'm studying computer science and mathematics. I'm also trying to go towards my master's in computer science here, so I'll be around for a while longer at the University of Florida. But I really look forward to holding discussion for all of you and meeting all of you. And hopefully it's going to be a really great semester. I have TA for Programming 1 before, but never data structure and algorithms. So hopefully you all get something out of it. I'm really excited to be a peer mentor for this course, and I think we'll have a good semester. Yeah. I guess one more thing about me, is I really like chess. So if you want to play chess against me, something, you can also send me a message on Slack. Hey, I'll play chess. I'll be like, sure. But mostly you can ask me questions from different Slacks. Yeah. But okay, objective sheets today. Introduction to TA or peer mentor with me, Josh, right? About the course. So next we're going to talk briefly about the course and then do a quick review of C++. A lot of you have probably taken Programming 2 before, so that's why it's a review. Hopefully you all know something about C++ anyway, but we'll go over stuff. Right? So about this course teaches a lot of topics that you'll see in technical interviews. So I think it's something that's really useful, right? If you want an internship and all that, you'll probably be asked technical questions. So this course really gives you a good solid foundation understanding of what you might be asked. So I think this is a really good opportunity for you to learn that. But also just in general, I think like a lot of the material covered in this class is really useful because a lot of times when you're working with things in computer science, it's nice to know how things work, why algorithms are written the way they are, and all that. And I think this course kind of gives you a good introduction to that. So, or a good foundation even for that. So hopefully you learn a lot about data structure algorithms in this course. I'm really excited. I hope you are too. But yeah, one thing is make sure you try and go the extra mile to fully understand lessons. Don't just memorize them, because really understanding them helps you not just like know it in the future, but allows you to apply it a lot more. Because a lot of times, even if a problem doesn't look like if you're trying to solve a problem, even if a problem like maybe doesn't look like a certain type of problem, maybe it's, I don't know, deals with graphs or whatever, and doesn't maybe not look like it. So really understanding that, you can kind of put little pieces together like a puzzle. And it's really fun once you get into it, hopefully. But hopefully you can learn a lot still. Okay, but again, today, this kind of review, right, C++. But we're gonna start with preprocessor directives. So one of them is pound include. We can do pound include IO stream, for example, and that includes the IO stream, right? It includes IO stream from like std. So you can do std cout, right? And that's what allows us to print something. So include allows you to like use your own files or other things from the language in the standard library to include them, right? Or yeah, I guess any other package or file. Pound define works almost like find and replace. It just finds all the instances of this thing, num items, and then just replaces it with 500. And this happens before the code even runs. So basically, it just sees anywhere there's num items, just imagine it's 500, just replace it. That's just how how define works. And then the next one is if define, if not defined, and end if. So these allow you to compile different sections if an identifier is or is not defined. And that's kind of useful, right? Because you may not want to run a certain section just something is defined. So that preprocessor directive is something pretty useful as well. The last one is pound private once. This is something that I remember when I was writing notes for Programming 2 is the first thing I wrote down.
I don't know why, but I remember anyway. Because it's something that you want to make sure that you put in a lot of your source files, because it allows you to make sure that the source file is only included once in a single compilation. And that's useful because otherwise you might have conflicts or something included from it once. Okay, it's not ideal, right? And then you may have things just not work. So that's useful to have in the top two. So this is the main preprocessor directives that you might remember or might use in C++. Data types, these are similar to Java, or if you remember them all from programming too, awesome, that's good too. But for example, you have char, which is 1 byte, it's a character, right? And strings in C++ really are just like, there's C strings, which are like C style strings, right? And strings, but these really are like arrays of characters. There's less of a wrapper than I guess there is in Java for strings, but they're strings, right? And they're ints numbers, right? Unsigned ints, longs, unsigned longs, doubles, and floats. And these two have decimal points, right? And then there's also like long longs, which allow you to have even more, like it's a 16 byte long or number, right? So bigger. Yeah. And then the other things, there's bool, which is Boolean in Java, like true, false, right? And void, and then string. So overall, a lot of things are pretty similar to you'll see in Java, or maybe you've seen. Okay, so auto and declared type. So these keywords can be pretty useful, right? Because they allow you to just like derive the type of a variable on the fly. And so for example, here if we use auto y equals x, we don't have to know what the type of x is. It's just going to infer it. And the same thing with here with declared type. It's going to infer that x, or that x is an int, right? So it'll assign that type to y in this case, because it gets the type of y of x to be int, so this is y, right? Basically is what it's doing. There are a couple differences between the two. For the most part, they're pretty similar. But for example, if you have like a reference to an int, is what x is. If you use auto, like you have like ints, oops, and then like ampersand, it'll infer y still if you use auto as an int, whereas declared type will give you the actual type, right? Because it'll get the type. The other main difference is that you have to actually include something, include a different package or file in order to use this, whereas this is built into the language itself. But yeah, that mostly covers auto and declared type. Okay, so full question. So for this, I'm going to ask you to go ahead and pause it. Well, we'll do the first one first. Go ahead and pause it, answer the first one, and then unpause it when you're done. Okay, so hopefully you've unpaused it. If you haven't unpaused it, then I don't know how you'd be hearing me right now, unless you like skipped ahead in the video, which I guess, I don't know, it's possible, right? Okay, yeah, so 412, right? It can be int, right? Because it's a number. Positive number, it can be unsigned int, right? It can be assigned int. And it can be unsigned int because it's positive, right? So if you're a negative number, we couldn't really use unsigned int because it's not. We wouldn't really use the double here though, because a double, right, has decimal point here, and there's no decimal point. So that would be like 412.0. And then on the right, we can go ahead and go to the next one. Pause it. Unpause when I say unpause. Well, actually, that won't work, right? Because yeah, we pause. You won't hear me say it. So unpause when you're done. All right, so I guess you're done. So if you got it, if you finished it, yay, good job. But right, this is a floating point number, right? It has a decimal point. So we would be using a float or a double. But we can't really use unsigned int or int because this is not an integer. And yep, ABC for the first one and CD. Awesome, good job, everyone. Okay, so for control flow, these all exist in Java, and you probably some programming too if you took it, right? There's if else. So it's like if this, else if this, and then else, right? So if it's not this one, in this case, right, if it's greater than 0, it's not, so go to the next one. else if it's less than 0, it's not, else. So if it's not less than 0, it's not greater than 0, right? It's 0. For switch case, we can switch, right? So we're looking for where the case where str is, right? So we look red or blue or default. Oh, it's blue, we go in here. The nice thing about switch case is it's kind of short to write. It's kind of nice that way. And yeah, if I put this as like orange, for example, instead of blue, then it wouldn't go to red, it wouldn't go to blue, so it would go to default. For while loops, I'm gonna go ahead and go ahead and pause and try and tell me what's wrong with this while loop. Maybe what could possibly be wrong with it? Okay, you can unpause. I guess you can unpause. Or maybe you never paused at all. But yeah, what's wrong with it, right, is like then it can go on forever because the while loop, right, it keeps going until this condition is no longer met. So while n is greater than 0, we just print it. So we keep going until, well, we keep going forever, right? But yeah, the main idea is just loops as long as the condition is met. For loop, you start with an assignment, then you have a condition, and some sort of change, right? So in this case, we're printing out I, starting from 0 all the way up until it reaches 100. 100 we don't print it. Okay, so pointers are really key to C++, and you don't really have access to them in Java. So it's pretty powerful, right? As you guys all know. But a pointer is variable. Its value is just memory of another variable. So really what that means is, you guys may know already, right? If I have some variable here, let's say I have some variable num, right? And num is 5, right? And let's say I have num in here, right? So num in here, and it's 5. Sorry for the handwriting. And this is the memory location, right? Somewhere in memory. Then if I had some other variable, right, which is a pointer, actually that's exactly the code we have here, right? We have x. And this is saying that x is equal to the memory location of num, right? So it's saying that x is a pointer and x is this memory location. It's not the variable, it's not the value in here, it's the memory location. And what this is saying, right, is x the pointer, right? That's why I ran it, right, with data type asterisk, which indicates pointer, and then the name of your variable. And this is the address of operator. So this is telling you get the address of the variable num, right? So wherever it is in memory. And then when we print it, right, when we print x, well, if we just print x, right, as we said, x is the place memory of this variable. So we just print x, it's just going to be the memory location. But here, if we put asterisk x, right, that's a dereference operator, which means it's like, okay, get the value at that memory location. So if x is the pointer, right, it's like, okay, dereference, then it's this memory location, just get what's inside of it, and then print that. So in this case, it's going to be 5, right? Num is 5. So hopefully that's a good review of that. Yeah, moving on. Oh, one thing, of course, is like if you guys have any questions about anything I say here, just message me on Slack or whatever. I'd be happy to answer. Pointers. So pointers continued actually. Yeah, and arrays and pointers are really closely related because arrays can be married to pointers the same type. So that means here we have this array numbers, and it's length 5, right? And really what this numbers thing is this numbers is kind of like just a pointer to the start of the array. So, but it's also the array, right? So, okay, right? So numbers is starting here. But now, what I mean by that is now if we make this pointer, right, equal numbers, it's going to point to the first element in the array. So it's going to point right here. So these two are now equivalent because if I print numbers of 2, well, of course, right, just like in Java or whatever, right, it's going to be this element. But if I do this, right, what this is doing is it's saying, okay, add 2 to the memory location, right? It's saying, okay, this is the memory location. Because remember, arrays are contiguous blocks of data. So it's like, okay, it's here. Now move 2 blocks of data down. And now, whatever is there, we want to get it. The way we get it is we dereference, right? Dereference operator. So we get the value inside of here. So that's why these are the same, right? And the important thing there is like, we're using pointer arithmetic. Pointer arithmetic is just like basically adding to the pointer, like moving where we are, right? because it supports addition and subtraction. And then here, for example, if this was 1,000, right? Then this would be 1,000 feet. Because when we add to a pointer, right, we're moving the pointer a whole block of data. And the block of data size is the size of the variable, or the size of, like in this case, it's an array of ints, right? So each block will be 4 bytes. So if we add one, right, it's going to move 4 bytes down. So here, for example, this is 1 block, right? This is 4 bytes over, and this is 4 bytes over again. So adding 2 here moves 8 bytes, right? Because it's 2 positions in memory. Okay, that's pointers. Again, distribute. Okay, arrays. So again, arrays very closely linked to pointers. And the way we declare them is the data type, the name, and the size. So like in this case, int grid, so it's a grid, and its size is 4 rows by column. And yeah, this is how you can also initialize it right when it's created. So something like this, right? We'll see that on the next slide, I guess. But same as you'd have in like Java. Okay, I guess it would be the same as having like int grid, and then if we didn't have this 4, 5 here, maybe equals, and then I could have like 1, 2, 3, 4, right? 1, 2, and like 3, and then a 4, right? With commas. Okay, but of course, like this is a 2D array. I'm just saying if it was like 1D array, right? But yeah, just like with Java, you access elements using the brackets. For a multi-dimensional array, it's an array of arrays, right? So it says an array, basically an array of like 4. Each of those arrays has 5 elements. The one problem with arrays in C++ is like getting the size, because if you think about it, right, there's no real way to get the size of it. The only way really to get the size of an array in C++, just a plain old array like this, the only way to get it, or let's say it was just int grid. Again, just for sake of argument, let's say it's 1D array. One way to do that would be to get like the size of grid divided by the size of grid sub 0. So you're getting like the size of the whole array, how much space it takes, divided by the size of one element. That gives you length. But of course, that's kind of like tedious, I guess. But like that's why we have a wrapper for it. So like a wrapper here is an array, and it allows us to use size, which is nice, right? Because you don't have to do that calculation. But there are also things like vectors, right? Vectors are nice because they're like array lists in Java, fixed size. So that's cool. Okay, moving on. Arrays as arguments. You can pass an array in as an argument to a function, right? And when we do that, we're passing the address of the start. So kind of like we did here, right? We looked at here, like it's this array here is really the start. Like the variables is the pointer to the start of the array. And that's what we're going to see here, right? Is when we pass it in, that's like what we're doing. So here, we pass in array 1, we're passing in where the array starts, or a pointer to the start of the array, right? Because that's what the array really is, the array variable, right? And then we get 5. So that's the length. The reason why we pass in the length here is because, again, it's an array. We don't have the array wrapper class, so it makes our life easier. But okay, this one kind of just like prints the array. But the interesting thing is what happens when we're on this side, right? On this one. Because if you'll notice, we actually need to include this and here too, right? And the interesting thing is, yeah, we need to include this when we pass in an array. We actually need to include the length of any dimensions after the first one. And the reason why is because even though you don't need it for the first one, you don't need it for the first one because it's an array, right? And with arrays, like there's the compiler knows, right, how long an array is. But the problem is because it's just a pointer to the start of an array, right? It's an array of arrays. So let's say I have this, and let's assume that all of these are arrays. Like, it's a pointer to the start of the array. But the issue is that even though the compiler will know how long this one is or how far to go, it's not going to know anything about these, which makes sense because this is just an array, right? We're passing in an array. So it wouldn't make any sense it might not make sense for the compiler to know that. It's a little more information than it may need. So in order to actually like tell the compiler, hey, this is how much size there is, we tell it explicitly. Again, store view, but hopefully if you've forgotten that, something good stuff. Okay. Dynamic memory. Yeah, so again, creating an array like that only works with a fixed size. If you want to have a variable size where maybe you take user input or something, you can't do it that way because it has to, the compiler doesn't know how big it is, which as we already saw can be a problem sometimes, right? So we do that as dynamic memory. So dynamic memory is when we use the new keyword in which you're putting data on the heap, right? So here, for example, we create an array, right, of like user input. Here we create number of user input, right, or a number of that's 3. And don't forget, whenever you have use a new keyword, you need to use delete keyword to clean it up. Okay. And yeah, if you don't, really, which actually brings me to the next slide. Yeah. So dynamic memory question. So go ahead and answer question 1, pause it, and when you're done, come back. All right, you're back. That was fast. For me, that was only a couple seconds. Yeah, it's so fast. Yeah, so what exactly are limit relays? Why do we care about them? Well, what are they is when you have some dynamically allocated memory that you don't free, right? And we care because that memory can no longer be accessed. And it can't be used by us, but it is wasted. And like there's only a certain amount of heap space. And if you use it all, for example, then your program's going to crash. Like it won't have anywhere else to go. So we need to make sure we delete memory, right? It's like allocated dynamically allocated memory, because if we don't, then we might have a problem, right? It can't be used. Good news is, of course, like our operating system does clean it up after we're done, after the program is done running, but we can still have the program crash if we aren't cleaning. Okay. Now what's the difference in next question, right? What's the difference between these 2 lines of code? All right, welcome back. So yeah, we saw these 2 lines of code in the last slide, except their names something different. But the main idea, right, is this creates an integer, right? A pointer, right? It creates a pointer to a buffer memory with a new integer. So it's creating the number 3, right? And it points to it. While this is just creating an array, basically, right? It's creating an array of length 3. So there's another important distinction, which is how we have to delete them. This one's just a pointer, right? So we have to delete using the delete keyword. But this one, we have to use delete followed by brackets. So this right here, because it's an array. That's how you delete arrays. Okay, now time for the last question. So for a linked list, right, how do we delete B without causing memory leak? Okay, wow, good job. So the way we do that is first we have to have a pointer to B and a pointer to C, right? And I guess a pointer to A as well. And the reason why we do that is first we want to assign, like we want to make the next thing in the array after A, C. So we make A's next C. But now, okay, now we're good, right? A points to C, C points to D. So that's what we have. Not quite, because we need to make sure that we don't cause memory leak. When we do that, this pointer to B is important. So we're able to delete B. So now we can just delete B. So we delete it, right? And now we're good. So yep. So as we said, leaks are unreferenced pointers, dynamically memory, right? Space memory, and it can cause the system to crash. And yeah, the first, as we said before, is a pointer to only an integer, single integer. It's cleaned up with delete. Second one is an array of pointers, right? Clean up with delete with the brackets. And here, you have to have a pointer to B and C. Set A's next pointer to C, and then delete. Okay, so functions. Functions in C++, if you remember from Java or you remember from C++, they're very similar, but there is a difference, right? Just that in C++, everything is passed by value unless you specifically make it pass by reference. So that includes like, I mean, that's pretty useful, right? Because that means even primitive data type like ints, you can pass by reference, but you can't do in Java, which is pretty cool. You have to use like a wrapper in Java to get that kind of functionality. So for example, here, if we want to square a, by default, this acts like how a primitive data type in Java would too. It passes a 4, right? Copies the 4, and it says 4 times 4 is 16. But this a is basically different than this a. And the reason why is because, remember, it passes by value. So this is a value. This has the same value as the other a, but it's not the same one. So when it prints, it just prints 4 because the one here is 4 and the one here is 16, 2 different variables. However, we can also pass by reference. When we pass by reference, it's the same block of memory that's changed. So now, when we do that in this, we do a equals 4, square a. So it passes in not just the 4, it actually passes the 4 from here, right? So when we multiply a by a, it squares it, and it changes this to 16. But this is also the variable used here. So we print it, it also prints 16. So remember, pass by reference, ampersand. Yeah, it can be very useful with complex data types because passing by value can be kind of expensive, right? Because it can, you don't want to have to copy, like you don't want to get to copy. So, yeah, for more info, go here. Structs and classes in C++, very, very, very similar. You can use either one. They're really interchangeable. The only difference is that members of a struct are public by default and members of classes are private by default. That's about it. Which means if you don't specify something as public or private, right, then in a class, that's going to be private, and a struct, it's going to be public. But if you define everything as private or public, then calling it as class or struct, not going to be. Okay, so templates. Hopefully, well, you might remember templates, right? A template allows you to create generic data type functions and classes. That can be useful for any data structures. And yeah, you can use them for any data structures, right? So for example, template type name T, this type name T, right? It means you can use anything, right? And here, if it's my type, like template type name, my type. So my type could be like an int, it could be a long, it could be a float. It doesn't matter. And that's what I think is really, really nice, is because it works with any type. It means that you can create it with, you can call this function with int or a float length or a string length, it doesn't matter, which is pretty cool. Which I guess you guys know, but still cool. And here, right, it returns my type and it gets max, right? So it's going to get the larger of the two. So if A is larger, return A, else return. Right, and as you notice, it works for int and double. Okay, so for class templates are templates on the type, right, for the class. So yeah, you only have to append it or add it right at the beginning of the class. You can say template type name T for a class linked list. So this is like, for example, you don't know what type linked list is going to be, right? It can be of type like int, type, string, type. I don't know, something else you make up like Andrew Kennedy is super awesome. Yeah, you should name all your classes that, all of them, because I mean, it's just true. I'm super. Okay, I'm just kidding. But yeah, you can prepend it before the class, but not its internal declaration. So for example, here, right, type name is T. So when we do set head T and data, right, it's saying that the type of the variable that you're using is T, right? And T again is whatever we created as. So yeah, there are a lot of uses for the implementation of templates. So again, let's learn more. Let's link. So another poll question, which the following are true templates. So one, we can write one template function. Okay, you know, I'll let you read it yourself and you can pause. Welcome back. Yeah, so all right, let's look at the first one. We can write a template function that can be used for all data types, including easy to find types. Well, is that true? I think we kind of saw something right here, right? It's exactly that. It's exactly the same, right? And yeah, the answer is yes, right? We absolutely can do that. Well, the next one, we can write one template class or struct and use for all data types, like linked list, stack, queue. Absolutely. I mean, that's exactly what we use in language, right? In like C++, right? So for example, we actually saw that here. We used it for linked list, right? Linked list was the template. How about the last one? And the last one is actually really tricky. And the answer to this is like maybe surprising, but yeah, the answer is it's not an example of it's actually an example of compiled time polymorphs. And the reason why is because it's not deciding at runtime like what methods are available to it. It's a compiled time. So it's not changing the behavior based on what type of object it is. So it's compiled because it behaves the same, right? So it's actually only 1 and 2. Okay, so const. So const is a keyword in C++. It's kind of like final in Java. But anyway, const indicates whether a variable can change or not. So on its own, right, seems pretty simple, right? Const data type name equals value, data type const name equals value. With both these, it means that you can't assign name to anything else. Same thing with final in Java, right? Not too tricky to do. But when dealing with pointers, right, const gets a little trickier. Because you have, let's say you have a pointer to an int, simple enough, right? But const pointer to a mutable int. So what this means is that in this case, you have a mutable int, right? So you have, it points to an integer, right? And that integer can change. So what I'm saying really is that this, if we have this, right, then what we can do is we can actually change the value inside of this, right? This points to, I don't know, right? This points to like some memory block. Let's say it points to a memory block is a 4. What we can do is we can actually change this 4 to a 5, and that is perfectly fine. We can like dereference the pointer and change what it's dereferenced to. Like if P is our pointer, or I guess X is already our pointer, we can do like, we can dereference it, right, and set that to 5. And that is perfectly fine. But what we can't do is we can't change what X is. So if I have another one, I have like, I don't know, int Q equals 6, right? What I cannot do is I cannot say X equals the memory location. So ampersand, right? Ampersand. It's really bad, sorry. Q. And I cannot do that because that would change the memory location of X, right? We can't do that, right? That would be changing the pointer itself. We can change what the pointer points. Well, we can't change what the pointer points to, or the memory location of the pointer. We can change what the value is where it's pointing. So that's for the const pointer to mutable in this one. Pointer to a constant. Actually, let me undo that for a second. First, yeah, but pointer to a constant is, yeah, the int can't change, but the memory address can. So what does that mean? It means that this example, we're changing it. We can't do that. We can't, like if the value inside of here is 5, we cannot change it. It has to stay 5. So we can't now, if we wanted to change that 5 to 4 like this, start asterisk X equals 4, I can't do that because you can't. But what you can do is you can change what X points to. So I can say int Q equals 6, and now I can do this, right? I change the memory location, but I can't change what's inside. But const pointer to a constant, you can't change either, right? Both are not okay now. Okay. Const objects and functions. So const can also be used at the end of a class's function declaration, right? So for example, here I can say, okay, this is a const function, right? Which means it doesn't change any of the variables that are given, right? It doesn't change this, right? It doesn't change what's passed in. In this case, nothing. It doesn't actually make a change to anything. And yeah, so you have an error if the function tries to mutate the state of the object. So in this case, right, const rectangle R2 to COP3 means that we can't call any functions that are not const because we can't actually make any changes to this variable, the rectangle. But if we do R2.setLength 5, setLength is not const because it makes a change, right? It changes the object. So if we try and do this, we're calling a non-const function. And so it's going to give us an error. And it's because the object itself is const, right? And it's calling a non-const function. So, okay. So how do we actually initialize const variables within a class? Okay, if you guys didn't remember this, the way we do it, right, is we say, we have to use initialize list. And what that is, it just looks like this as a syntax port. And it's saying that the length, we set the length to L, whatever L is, and we set the width to W, length and width to L and W. And this basically allows us to initialize them when an instance of the class is created, but then they aren't ever changed again. So right when I first create a rectangle, right, it'll create it with these dimensions, and those dimensions cannot change. So yeah, right, constantly for reading. So that's that. So that actually covers our review. Hopefully, if you forgot anything, this kind of covers everything to it you might need to remember. But one thing I really want to say is please don't cheat. You're better than that. And I know you are better than that because I know you're all good enough on your own to do really well, of course. I know you are. But please don't cheat. If you do, it can ruin, your academic and professional career can get in a lot of trouble. And I don't want to say I get in trouble. I want to say we're in you can't cheat on workforce projects, and this is actually like really true. There's no one cheat off it. I mean, and you have to know something. Like you have to know stuff in order to like figure out what you're doing. So yeah, if they figured out that you cheated, like if you have an internship, right, then you might get yourself in trouble. So anyway, cheating is copying or pasting other people's codes. Like none at all. Don't do it at all. Giving away, showing, or selling your own code, don't do that. Using code from online sources and not citing it, that's a no. Copying from projects and assignments in the previous semesters, definitely not. And stealing code from other people's GitHubs. And yeah, this actually happens, and I know it happens because I've seen people do it before, and they got in trouble. So really, if you do that, you will get in trouble. So do not do that. But okay, that's about it. Yeah, additional resources on C++ are these. That covers this entire review. Really excited about the semester. And yeah, if you have any questions at all, feel free to reach out to me. However, I think that's it. So I'll stop sharing now and have a great rest of your day.